Measuring the capacity of a battery or a battery pack. Why would you do it, and how do you do it? Well, why? You can buy these on eBay fairly cheap, and you don't always know what you're getting. I happen to know this pack works. It's an 8800 milliamp hour battery pack. It works with the camera that's actually filming this, so I know this is actually good. But you can get things on eBay that they say that they're a high milliamp hour battery, but they're really not. Also, you can buy these at the store. You can get these on eBay. I actually bought these on eBay really cheap. These are 2500 milliamp hour nickel metal hydride rechargeable batteries. And at the store, these are about 15 bucks. I got 2 packs for $15 with free shipping. So it was a really good deal. The question is, why was it a good deal? Are these batteries shot, or is just somebody just had too many of them and they want to get rid of them? So that's what we're going to test out today. The way that you test this is you apply a load, a constant current load, across the battery, and then measure how long it takes for that battery to discharge, and that's where you come out with the milliamp hours, or how many milliamp hours the battery is. Now this is a basic circuit. It's based off of a 7805 5-volt regulator, and because the ground is tied to the output past this resistor, it's going to change the voltage that it's pulling from the battery as the battery depletes. So it's going to keep a constant load across the cell, and that's what you want. You don't want a constant voltage, you want a constant load, or a constant current. This is a DC in because you're going to need more power than the cell can actually provide to drive the chip, or the 7805 regulator. Now this resistor here governs what load is actually placed on the cell, and I'll show you how that works. So here's the actual board. I just threw this together using scrap parts. It's not pretty, but it works. So the way this circuit works is I have 7 resistors. They're all 120 ohms, and that's just pretty much what I had laying around. So I grabbed them and threw them in there. And that way they will all share the load. So instead of burning out one resistor, they'll all share the current across all of them. And it comes out to be about 17 ohms. If you notice here, these are all silver bands, so it's within 10% tolerance, so it's not exact, but close enough. So that should put out, with this setup, it should be about 292 milliamp load. And the way we get that is the current is equal to 5 divided by the resistance. Within 10%, because like I said, they're silver banded resistors. The other thing is I installed 2 posts here so I can monitor the current going through the circuit with an ammeter. This switch here just bypasses it. That way, if I don't have an ammeter hooked up, I can just swap flip the switch over. It needs DC voltage in from an external power source, because the single cell is not enough to drive the voltage regulator. There's a switch here, and this switch basically just disconnects the cell from the circuit. That way, if I want to check the voltage of it without it being connected to the circuit, I don't have to remove the cell. And I put a little LED in there. I didn't put that on the schematic, but that's just so I know it's plugged in and charged. And then there's a protector, or protection diode, with 0.7 reverse bias voltage. And that's pretty much it. It's a very simple circuit. It's not perfect. If you go to use this with a lithium battery, you really want to monitor it. You do not want to flatten the lithium battery completely. So really, this is only safe to be used with NiCad and nickel metal hydride. You can use it with lithium. Just you want to keep an eye on it. So how do we actually measure milliamp hours? Well, what we do is we take the milliamp hours of the battery, which are 2500. We divide that by the current load, which is 292 milliamps, and then we multiply that by 0.7, and that equals 5.8 hours. If that makes any sense. And that's how long the battery should last at this current. So at this current, it should last 5.8 hours. So we're going to put it in, we're going to plug it in and give it a shot. Now, first thing I got to do though is charge these, because these batteries come, I already opened one pack, and as you can see, gotta get a better lighting setup. This lighting setup sucks. As you can see, these are completely dead. I mean, they're just a direct short circuit. So I got to charge these up first before I use them. And I might actually even run them through a couple cycles first. So once I do that, I'll put the test on, we'll set up a clock, and then we'll figure out what happens. Actually really well. We're dog sitting at the moment, and the dog's not happy about it. Around the 5 hour 40-minute mark or so, you notice that the voltage really starts to drop off, and then once it hits the 0.7 volts, it just flatlines, and that's most likely because of the diode is in place there. So if we do the math, 5.8 hours, that's pretty close. It's pretty close to the 6 hour mark. So I would say that, yeah, these batteries do hold their own. I had to cycle them a few times, charge, drain, because the first pack that I opened, and that's what kind of prompted me to do this, is I tried using them in just a regular, camera, and it lasted for about 15 minutes, and then they were completely dead. And it made me go, yeah, these weren't good batteries. But then I tried it again, and they lasted longer and longer and longer. So probably sitting dormant, they needed to be primed, or they needed to be just charged up and cycled a few times. So if you were to buy these batteries and they're not, like I said, if you buy this exact seller or something similar where they're not charged, you're going to have to go through and cycle them a few times to get the best use out of them. So I hope this was in some way helpful, and if you have any questions, leave them in the comments, and I'll see you next time.